Hi, it's Glenn and Joseph here, and we're going to go through these answers with the letters E and S so that you could understand, right? So E and ES, right? So E is the free enzyme, ES is the enzyme substrate complex, and number one, the inhibitor binds to the E or to the ES. So this is good and this is good. They're both good, but it prefers this one. So this one is better. And so what is that called? What is that called, Joseph?
Mixed competitive.
Okay, that's mixed. That's good. You know, I'm not sure why I put competitive. Maybe the book called it competitive. But if you just learn it as mixed, you'll be fine. All right, so now what about this? So let's do it with the E and the S again. So they're the E and the S. So here it's binding to the E, and it's only binding at the active site. In the ES, the active site is occupied by the S, so it is not binding there. It is not. How do you strike through? Strike through. So it is not binding to the ES. Only the E. So what would that be?
Competitive.
Right. That'd be competitive. So let's look at this one. So this one is binding to the E or the ES, and the ES is good, and the E is good, and they're equally good. No preference. So what would that be?
No preference, no competition, so it's non-competitive.
Ah, good. Non-competitive. Oh, that's an interesting way to remember it. I wouldn't have thought of that. An inhibitor binds to the free enzyme, the free enzyme or the enzyme substrate complex, all right? But it prefers, okay, so both of them are good, but it prefers the free enzyme, all right? So let's see. Let's look at this free enzyme, all right? So which one would that be? There's a preference.
It would be mixed.
It would be mixed. Okay, now let's look a little deeper here. What kind of mixed would this? What would happen to the Km if the inhibitor is binding to if the inhibitor is binding to the free enzyme? If it prefers to bind to the free enzyme, does that mean to us, the observers, the enzyme seems to be stickier or less sticky?
So the Km would increase. It would be less sticky.
Yes. If it's only binding to the enzyme, it would be less sticky. Or if it prefers the enzyme, it's going to end up looking less sticky to us, according to our data. Less sticky means increase of Km. Correct. Was that number 3? Was that example number 3 in these pages, or number 5 in these pages? Which one was that?
Case number 3.
Case number 3. You got to understand that, folks, okay? Let's go back. Let's backtrack to number 1 over here. What was this? If we prefer the ES, what happens to the Km? So this
Km would decrease, which means it would be stickier.
Yes, yes. If it prefers the ES, that means the ES is locked in place by the inhibitor, not coming off. So that's stickier. That means, what was that? Increase or decrease of Km?
Stickier is decrease.
Yes, stickier is decrease of Km. So that was example number 5?
Example number 2.
Wait, no. If it was mixed. So if it's mixed. So example number 2 is not mixed. Example number 2 only binds to ES. So that was uncompetitive. But if it binds to E and to ES, but it prefers ES, same thing happens to the Km. The Km decreases, but the Lineweaver-Burke lines look a little different because it also can bind to the E, right? So this is going to look like example number 5. Example number 5, is that right? The Km in example, let's go look at it together. So the Km here in example number 5, no, that's number 4. Where's number 5? Oh, number 5 is gone? Oh, sorry. Okay, so I don't have number 5 in these particular pages, but I can go get it real quick so you could see the Km. This is getting stickier. So Km is supposed to be decreased, right? So let's go get number 5. What was it called? Enzyme inhibition. Yeah, there it is. So enzyme inhibition. An extra copy of this. Looking for page 5 down here. Page 5. All right, is this page 5? Is this number 5? Nope, that's number 3. Oh, I only have up to number 3 here. Okay, I lost number 5 somehow. So you guys look at number 5, and when you look at number 5, you're going to see that the blue line crosses the x-axis to the right of the red line. So from blue to red, that means the Km decreases. So that means it gets stickier. The enzyme gets stickier, right? So this number 1 here is the mixed inhibition of type of the same type as example 5. And now here's problem 5, not example 5, but problem 5. What have we got here? We've got E and ES. So the inhibitor binds to the ES only, and it doesn't even touch the free enzyme. So let me strike through that, strike through. So what is that? Strike through. Yeah.
Uncompetitive.
Okay, that's good. That's uncompetitive. All right. And then let's see. So what about number 6? This is confusing. The inhibitor binds to the enzyme only after the substrate has bound. So which one is that? E or ES? Which one is the enzyme after the substrate has already bound? Which one is that?
It would be ES.
It would be ES. That's right. It would be ES. And so if it doesn't bind to the other one, I'll put an X there instead. It only binds to ES, then what is that?
Same as number 5.
Right. Same as number, no, uncompetitive. That's called uncompetitive. Yeah. Uncompetitive.
Oh, right. Uncompetitive.
Non-competitive was number 3, where it binds to E and S equally well. That's it. Thank you. Thanks, Joseph. Hey, say thanks. Say thanks, folks.
Thanks, folks.
What program are you using to record?